Last time, we were talking about IRR. What does IRR stand for? Internal rate of return. And what's the definition of IRR?
The discount rate that makes the net present value of a project zero.
Very good. She had to read it, but at least she knew where to find it, right? Okay, so, and the rule. What's the rule? Accept all projects with... Oh, yes, that's the TV rule, and you're absolutely right. But what about for IRR?
An IRR greater than the discount rate.
Yeah, an IRR greater than the discount rate. And so that's what we're getting ready to do here. We're going to look at a project, and it tells us an investment of $200 today gets you $100 a year for the next 3 years. What is the IRR? So we told you last time that if you did this by hand, you'd be in a world of hurt. So we're going to use our TI BA2 Plus. And we are going to use the CF keys. CF, second, clear work. Why do we have to clear it out? Yeah, if there's stuff hiding in there past these number of cash flows, we'll be in a world of hurt. Okay, so an investment of $200 today. 200 at time zero, negative. Why is it negative? Yeah, it's cash outflow. And then arrow down. What is C0? 1. 100. Now, can anyone tell me, and you got to hit enter or it's like it never even happened. Why would we put 3 in for F01?
Constant cash flow.
Yeah, it's constant cash flow and it goes on for 3 years. Now, what if it had gone 100, 100, 0, 100? Could we have done that? No. If it had gone 100, 100, 0, 100, we would have had an F01 of 2. Then we would have had a C02 of 0 with an F02 of 1. And then finally we would have had a C03 of 100 with an F03 of 1. Okay, so we got all that in there. Now it's really, really mind-boggling here what we're going to do next. What button do you think we should hit next? IRR. Oh man, it says the IRR is equal to 0.
Compute.
Yeah, see, it's telling me right up here I need to compute something. Compute. And there it is. By the way, this star means that this is a number that the calculator came up with. This is a number of it's not something you entered. So here's what I'm going to do. I'm going to say store 1 because I'm going to prove something to you. Okay, now take a look. If we go to NPV, and I'm going to say recall 1, enter. Because remember that the IRR is supposed to be the discount rate that makes NPV equal to 0. So I put that IRR in there, I hit enter, and I'm going to arrow down, and then I'm going to compute the NPV. Now notice right now there is no star, but when I hit compute, now we get this star, and we get this weird looking number here. 1.28 times 10 to the negative 11th. In case you are unfamiliar with scientific notation, here's how that works. We are actually looking at point 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 2, 8, right? Can we agree that that's pretty much 0? Yeah. So keep in mind that 0.01 here would be 1 cent. And so we're looking at like fractions of a penny. You guys wouldn't even bend over to pick up a penny on a sidewalk, would you? I wouldn't. You don't know where that's been, right? It's only worth a cent. Okay. Now, when you're on the and of course it doesn't do it on the computer, but when you're on your calculator, you can actually notice when you hit the compute button on IRR, it takes it a while. It takes it longer than when you're computing NPV. And the reason is NPV is just solving a formula. It's just, solving this formula, which is easily done. But if you are using the IRR, you are making the calculator guess. It's iterating. It's doing the guessing for you. That's why it takes longer for this thing to pop up in your calculator than NPV. Questions? What's that? No? Okay. Oh, you were asking if it took longer?
Yeah,
Yeah. Where's your calculator?
I changed my bag today, so I left it
What's the purpose of the bag?
to hold that.
to hold your calculator, right? Among other things. Let me guess, was that where your hairband was?
I still got my hairband going too tied up.
Oh, okay. So he's got it on his wrist. Yeah, my wife does that too. Okay. I have talked to Mr. Sadai and I said, anytime I get too rough on you, let me know. So far, he has yet to push back, so there we go. Okay, so let's talk about IRR and the investment rule criteria. First of all, does IRR account for the time value of money?
No.
Oh, swing and a miss. Ms. Volkova. She's gonna say yes. Oh, I should have thrown that to someone that really needs a win, but, so let's ask now, Mr. Taylor? No, Zach Scott. Mr. Scott. Why? How does it account for time value of money?
Because it's telling you the cash flow of each year.
Yeah, we're looking at the cash flow each year and we're finding out it, and we're, by the way, we're comparing this thing to the discount rate, right? But we're figuring out what is the actual rate of return, but time value of money very definitely comes into play. So far, 1 star. Does it account for the riskiness of the cash flows? Ms. Craybill?
Yes.
Yes, very good. How?
Because of the discount rate that's taken.
Yeah, exactly. We're comparing to that discount rate. Okay, and then finally, does it provide information regarding the wealth created by the project? I'm going to throw this one to Mr. Fisher. Mr. Fisher, what do you think?
Yeah.
Yes. Does anyone think no? I'll actually accept both answers here. And here's why. It does let you know whether or not you're creating wealth. If the cash flows are normal or conventional and the IRR is greater than the discount rate, then you know you're creating wealth, but you just don't know how much. Remember, NPV tells us dollars and cents what our gain is going to be in wealth as a result of taking on the project. And so I'm going to give IRR 2.5 stars. I'm going to give IRR 2.5 stars. And I can't give it 3 stars because it doesn't tell me how much wealth gets created. Questions? Okay. So let's talk about some problems with IRR. The first one is independent versus mutually exclusive projects. Independent means that you could do both of the projects. So you could come to Missouri State and get married, right? You could do both of those things. They don't exclude each other. But many of you were undoubtedly also accepted to the MBA program at Harvard. And you had a choice. You had to choose between MSU and Harvard. Now I've got good news for you. Oh, by the way, these projects are mutually exclusive, right? You couldn't do both. You couldn't do both. So I've got good news for you. You made the right decision. Number one, we know it's cheaper, right? Number two, the colors are the same. And number three, you guys know about avoiding the single cost of capital, whereas apparently those Harvard people don't. So there you go. Okay, mutually exclusive projects. Another example, 2 people offer to marry you. Under the laws of this country, those are mutually exclusive projects. Does that make sense? Okay. So, we have 2 projects here. We have a street corner in Los Angeles. And Los Angeles, it's hot, dry, dusty, pretty much year-round. So, you could do a couple of things here that might be really profitable. The first one is a snow cone stand. If you're unfamiliar with what a snow cone is, you might have thought of it as shaved ice. That's what they call it in Hawaii. They call it shave ice. And it's basically just snow with a sticky, syrupy, liquid fruit flavor over it. So that's a snow cone stand. And the other would be a swanky nightclub. Can anyone tell me what the word swanky means? What's the word swanky mean? No. The guy behind you who looks like he knows what he's doing, whose name I always have trouble pronouncing. You don't know. Okay, so swanky is fancy, right? Swanky is fancy. So I asked this question in my class in Mississippi, and this girl said, I said, what does swanky mean? She says, slutty? And I said, no, that's skanky, but thanks for playing. Okay, now, here's the problem. Both of these projects, I can only do one or the other. Now, some students are like, hey, can't you sell snow cones out of the nightclub during? No, we can't, because of liquor laws and whatever. So we can't do that. So, two mutually exclusive projects. Miss Avila. Yes?
There technically is a club down in Springfield that is a club and also sells ice cream outside.
Outside. Ah, yeah, so there we go. For the purposes of this example, let's just assume.
Drop sells like slushies.
Oh my goodness. So in Louisiana, and this is 1996, this is like, it just blew my mind. They have these drive-through daiquiri stands, which sounds like a monumentally bad idea. And what they have is, they have lids, and if the lid's on it and taped, they tape the lid, it's considered a closed container until you poke the straw through, right?
There's one in Texas too.
Yeah, and so, but to me now, Mr. Ware, or I mean, sorry, Mr. Taylor, are you familiar with this?
Yes, sir.
Yes. I'm not going to ask you how often you drive through, but my Cajun buddies, like they pull through, what do they immediately do? Strip the straw, stick it in. I'm like, dude, that's against the law. They're like, chill out, man. Back in the 80s, we used to smoke weed while we drove. Okay, back to the story. We have to look at these two projects, and the way we're going to examine them is with our TI BA2 Plus. So get your calculator back up and ready. I'm going to hit CF second. Clear work. Now, cash flow times 0 is 100. By the way, we're going to have to invest 100 up front. Enter. Arrow down. Then I'm going to get 50, 50, 50 for the next 3 years. So I can hit 50 for C01. What do I put in for F01? Yeah, very good. 3. Enter. Now, if I'm going to calculate IRR, what button do I hit next? Mr. Holman. What button do I hit next? To calculate IRR.
Was it IRR?
Oh, very good. We're going to hit IRR. And then what button do we hit after that?
Compute.
Very good. Compute. Now, watch as it guesses. Yours is going to be slower than mine. Now, I want you to go ahead and write this number down, then we're going to talk about this number, 23.375. Does that look familiar?
That was what we had originally.
Yeah, that's what we had earlier. Are they the same numbers? No, previously we had 200, 100, 100, 100. And the point here is that as long as these numbers have these proportions, we will always get the same IRR. For instance, if this was minus 100,000, 50,000, 50,000, 50,000, we would get the same IRR. If it was minus 2, 111, we would get the same IRR. So it's always going to be 23.375% when it's that pattern of numbers. So have you written down 23.375 on your slide there? Okay, now while we have all this in our calculator, I want to go ahead and compute NPV. So I'm going to arrow down, and I haven't told you this yet, so we're going to hit NPV. I haven't told you this yet. It turns out that snow cone stands and swanky nightclubs are exactly equally risky as each other. They both require, I can tell Mr. Green doesn't believe me, they both require a 10% return. So here's what we're going to do. We're going to put in this 10, enter, arrow down, and then hit compute. So we have an NPV of 24.34 for this. Now we know from the IRR that we should accept the project because 23.375 is higher than 10. And we also know we should accept the project because 24.34 is greater than 0 if we were using the NPV rule. So this is a good project in and of itself. Okay, now, by the way, go ahead and write that NPV down. I gave you a box just to do that right there. And then I'm going to hit clear CF second clear work. It turns out it is 10 times as expensive to build a swanky nightclub as it is a snow cone stand. So we're going to start out with 1,000, a negative, enter. Arrow down. What do I put in for C01? 450, very good. Enter. Arrow down. Mr. Isawagwu, what do I put in for F01? Yeah, 3. Enter. Okay, now if I want to compute the IRR, I'm going to throw this one to Mr. Bauerrichter because I figure he's got COVID brain fog, but I'll bet he can get this. What button should we hit to calculate IRR?
IRR.
Oh, very good. He says IRR. And what button should we hit after that? Compute. Very good. So I'm getting an IRR for this one of 16.649%. 16.649%. If I were solely using the IRR to choose between these projects, which would I choose? The IRR of the snow cone stand was 23.375%, and here we have 16.649%. What sounds better to you? Yeah, the first one. The snow cone stand sounds so much better. And if they were both, I know, we'll get to that in a minute. Okay, so let's go ahead and do NPV. And remember, they're equally risky. I'm going to put a 10 in there, enter, arrow down, and then what am I going to do? Compute. I'm getting 119.08. Go ahead and write that down. 119.08. Is that greater than or less than the NPV for the snow cone stand?
Great.
It's greater than, and it's quite a bit greater than. Now, what is the goal of financial management? Say that one more time. Yeah, maximize shareholder wealth. Because either one of these projects will raise shareholders' wealth, right? But only one of them maximizes shareholder wealth, and it's going to be the Swanky Nightclub. And so I'm going to choose the Swanky Nightclub. So IRR for mutually exclusive projects can lead you to the wrong decision. IRR for mutually exclusive projects can lead you to the wrong decision, and here's the reason why. It fails to take into account the scale of the investment. If I told you I had an investment that can pay 23.375%, you're like, woohoo! And then I say, but you can only put $100 into it. It doesn't sound quite as good now. But if I tell you there's a project that pays 16.6 to whatever it was, 649%, and you could put 1,000 into it, that sounds a little better. It gives you a greater increase in your wealth. Now, of course, we assume that we can always get money if we have positive NPV. And so either one of these are doable. Now, here's the next question. What if these were independent projects? What would we do? Yeah, you'd accept them both because they're both positive NPV projects, and the rule is accept all positive NPV projects. The only reason we can't accept them both is because they are mutually exclusive. Any questions? Okay. So here's another problem. And that is if we have what are called non-conventional or unconventional cash flows. Non-conventional or unconventional cash flows. What does that mean? Well, let's talk about what conventional cash flows look like. Conventional cash flows start out, a little lightheaded. Conventional cash flows start out negative as we make our investments. But then we hope they eventually turn positive and they remain positive. So if you only have one sign change going from negative to positive, it's a conventional cash flow. Now, it doesn't have to just be time 0 negative. You could have 0, 1, 2, 3 be negative, and then at time 4 switch over positive, and you would still be okay. It's still a conventional cash flow. But what if we have more than one sign change? If we have more than one sign change, it turns out that we have more than one IRR. And so that starts to mess with our thinking. Now let's talk about why you might have more than one sign change. If you're going to go out and build a gasoline station, by the way, did you know that you have to bury tanks for the gasoline? When I was in Louisiana, the secretary asked, how do they know where to put the gas station to get the gasoline out of the ground? Like, she thought they were like drilling for oil and refining it all right there. I'm like, no, that's not how it works. There are big tanks in the ground and they get filled. Now, what do you think happens to those? By the way, so you got to bury the tanks, you got to build a building, you put in the pumps, the whole thing, and you're ready to go. And so in the beginning, you're going to have negative cash flows while you build the station, and then you're going to have hopefully positive, 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 positive while you run the gas station, convenience store. And then at the very end, the government makes you do something weird. They make you go in and dig up the tanks. Why do you think they make you dig up the tanks?
You can't just leave them there.
Good. People did for decades.
Well, we found out that that's not.
And why was it a bad idea? What do you think? Okay, what do you think these tanks are made out of? Do you think they're made out of like gold? No.
Say don't the materials like decompose? or,
Yeah,
like,
they're made out of carbon
deteriorate?
steel. They're made out of carbon steel, and they put something called a sacrificial anode or something, a big block of magnesium on them to try to pull off these electrons that are going to cause trouble. But eventually, that thing goes away, and the tank rusts. And what happens when the tank rusts? It leaks. And so what you have to do at the end of the project is go dig out that tank, scoop out the soil around it, and send it off for incineration to get rid of any little last remaining bits of gasoline that might be in the soil. And so you've got negative when you build it, you got positive through the years when you run it, and you got a negative again at the end. And that's true also with strip mining of coal, where you basically go in and knock off the top of the mountain. That's a big negative cash flow. Then you start scooping coal out of the mountain and you have positive cash flows over the life. And then the US government makes you do something really weird at the end. You know what they make you do?
Put the top of the mountain back.
You have to put the mountain back, right? Now, when you knock the top of a mountain off, gravity helps you. What do you think gravity's doing when you're trying to put the... It hurts you, right? Okay, so you got this big negative cash flow at the end. So I'm telling you, these things do exist in the real world, so don't just dismiss it. Okay, so we have a project here that meets this criteria. It's got a negative cash flow, and I know you're used to seeing them vertically, now we're horizontally. Usually you're seeing, or you've got negative 100 at front, and then you've got a positive cash flow, so far so good. But then we've got this crazy negative cash flow in time 2. And so what happens? Let's go ahead and put this into our calculator and see what we get. CF second, work. What should I put in for CF0? 100 negative, very good. And I gotta hit enter or it's like it never even happened. Arrow down, what is C01? 230. Enter. Arrow down, what's that 01? Just one, because it only happens once. C02, what's it? Yeah, 132, negative, enter. And I don't even have to do this, but F02 is going to be 1. Now to find out what the calculator thinks IRR is, I'm going to hit IRR compute. And it tells me 10. Now let's see if that truly is an IRR. I'm going to go to my NPV, I'm going to put in 10, enter, arrow down, compute. And it's telling me it actually is an IRR. And so what you would do if you weren't thinking about this is you would say, aha, the IRR is 10%. Therefore, if the discount rate is, say, 8%, I will accept it. If the discount rate is 12%, I will reject it. But here is what's going on. What if I also put in 20? 20. Oh, sorry. Yeah, I need to go, no, I need to go arrow up, right? I go 20, enter, arrow down, compute. Now, you remember earlier when I did the little dance for -11? Just add 2 more steps to that, right? And so what we're talking about here is a number that's far, far, far below even 1 cent. And so basically what we know we've done is we have hit another IRR. Now, would your calculator tell you about that other IRR? Let's go back and try again. I'm going to hit IRR, compute, and then I'm going to see if I can arrow down and get it to show me more. It doesn't. It turns out your calculator is lazy. Your calculator gets to the first one and says, woohoo, I found it, and then it stops, right? You're smarter than that. You know, because of this pattern of cash flows, that there's going to be more than one. In fact, if there were, we've got 2 sign changes. What do you think would happen if there were 3 sign changes? How many IRRs do you think there would be? There'd be 3. There's going to be 1 IRR for every sign change. And I'll show you how that happens. So here we have a graph. And on the vertical axis is NPV. And on the horizontal axis is the discount rate. On the horizontal axis is the discount rate. And so what we've done is we have plotted NPVs for each discount rate. And you can see that it's only positive between 10 and 20. And so we should only be accepting projects if the discount rate is between 10 and 20. If it is below 10, then the NPV is negative. If it's above 20, then the NPV is negative. Now let's talk about the IRR rule. The IRR rule says to accept the project if the IRR is greater than the discount rate. So let's make it easy here. What if the discount rate is 5%? Can you kind of see where that would be on this chart? Yeah, it's going to be, the NPV there is going to be negative. So the IRR rule is telling us to accept the project. NPV is telling us to reject it. Which one do you believe, Mr. Hawkins?
The
NPV. NPV, if you put the right information into it, you'll always get the right answer with NPV. So far, we've demonstrated that IRR can lead you astray when there are mutually exclusive projects. It can also lead you astray when you have more than 1 sign change. Questions? Okay. So why do people still use IRR? We've discussed that NPV is a 3-star method. IRR is only 2.5 stars, and occasionally it can actually lead you to the wrong conclusion. And so why do people still use IRR? It's because it sums up a project in a single number that people have feeling for. We have a feeling for it. So let's ask, who are our marketing people in here? I think Mr. Fisher, are you a marketing guy? Let's ask Mr. Fisher. If I say this project has a return of 2%, what do you think? That doesn't sound very good, right? What if I tell you that the return on this project is 30%? Yeah. Okay, so he has a feel for that, and the feel is based on what he's getting at the bank, car loan, home loan, that sort of thing, right? We have a feeling for what these things should be. Now, here's what I would tell you. By the way, most of the people who end up in the CEO's office, do you think they're finance people? No, what are they? Mr. Fisher, right? There is hope for the future. Okay, so what am I telling you? Will those marketing people, and I guarantee, I'm going to ask Mr. Fisher here. Mr. Fisher, 20 years from now, when you're in the CEO office, do you think you'll remember NPV?
No, but I will remember this class.
You will remember the class. And you'll probably remember some of my dirty little stories, but you probably won't remember NPV. Now, why am I telling you this? Because if you need to sell a project to a CEO who's not a finance person, which is entirely likely, then IRR is a good way to do it. But you only want to push the IRR on positive NPV projects. Because otherwise, if I said, oh yeah, 37%, but the NPV is negative, what's Mr. Fisher going to say? Oh yeah, right? I'm like, wait a minute, this is extraordinarily risky stuff we're talking about here. People could die, everything could just go crazy, and he's like, 37%, well, let's do it, right? So this is a way to sell projects to senior managers who can't remember what NPV is. And another one is if the IRR is high enough, you might not even have to find that appropriate discount rate to compare it to. So for example, replacing the company pickup truck. It's got an IRR of 45%. By the way, where is the positive cash flow from replacing the pickup truck? It's not positive cash flow, it's avoiding the negative cash flows of maintenance. And we'll get to that in Chapter 8. Okay, so do I really need to know whether that appropriate discount rate is 7% or 11%, knowing that the IRR on this project is 45%? No. And so it might save me some work versus NPV. Questions? Okay, so now we are on to the Profitability Index, or PI. And using the definitions from the book, we've got Profitability Index is equal to the present value of cash flows subsequent to the initial investment. What does subsequent to mean? After. So it's basically the present value of cash flows that come in after the initial investment. Now it's assuming that all investment happens at time zero. That is one flaw here. It assumes that all investment happens at time zero, and then you divide by the initial investment. But I could substitute, because you remember that the NPV definition is that present value of all cash flows subsequent to initial investment minus the initial investment. So all I got to do is solve that equation for present value of cash flows subsequent to initial investment, and that gives me initial investment plus NPV. And so I could do a little distributing there and have initial investment over initial investment plus NPV over initial investment. And what would happen to that initial investment over initial investment? Yeah, it's going to cancel out. It's going to give us 1. And so really all we're looking at here is 1 plus NPV divided by initial investment. Now I want you to make a very big, careful note here. Are you ready? Initial investment is always positive. Initial investment here is always positive. The initial investment in this formula is always positive. Let me say that one more time. The initial investment here is always positive. I know you're used to putting it in as a negative for C of 0, but in this case it has to be positive. Now we can actually, now that we've got this thing in this form, 1 plus NPV over initial investment, we can actually put, we can actually come up with the rule for this thing based on the rule for NPV. What's the rule for NPV? Accept a project with NPV greater than 0. Any NPV that I put in here that is greater than 0 is going to result in this thing being greater than 1. Anything I put in here, NPV greater than 0, is going to give me a PI greater than 1. So that's our rule. We're going to accept all projects with PI greater than 1. And you say, well, wait a minute. If we know NPV, why are we even doing this thing? And I'm going to show you why that is. But first, we'll talk about the ingredients. What do we need? First of all, we need the initial investment amount, the future cash flows and the timing, and the discount rate appropriate to the future cash flows. Those look familiar because that's all the ingredients for NPV, and by the way, NPV is actually in this thing. So that makes perfect sense. Now let's ask these questions. Number 1, does it account for the time value of money? Ms. Wabi, what do you think?
Yes.
Yes. Why? How?
NPV is.
Yeah, it's got NPV in it. Very good. Okay, does it account for the riskiness of the cash flows, Ms. Perry? Yes. And how does it do that?
Because it's accounting for the discount rate.
Yeah, the discount rate that we used to find in
Initial, or
PV.
each one.
Yeah, very good. And then finally, I'm going to ask Ms. Robinson. This one's difficult, but you've got a 50-50 shot of getting it right. Actually, you've got a 100% shot of getting it right. Does it provide information regarding the wealth created by the project?
Yes.
Yes, she says yes. Does anyone say no?
If it's 100%, that must be.
Oh, yeah, I was going to say, both of them have to be kind of right, right? Now, so it turns out that this thing does provide information regarding whether or not we are creating wealth. We know if this thing's greater than 1 that we're creating wealth. But in the absence of any other information, if I just tell you, yeah, PI is 1.5, does that tell you how much wealth we're creating? No, we just know that we are creating because PI is greater than 1. So, how many stars do you think I'm going to give this, Mr. Umsley?
2.5.
2.5 stars, exactly the same as IRR. Now, when is this thing useful? Because so far, we could have just been using NPV. And the answer is during times of capital rationing. That means we don't have an endless amount of capital available. Remember I told you about when I first went to work for Halliburton that we could not get funding. We had to deal with our internal cash flows only. We couldn't get funding from outside. And so we were under capital rationing. And you're going to see that this is true in a couple of other situations. Let's think about startups. If you're a startup, do you think people will just throw, I shouldn't say that because nowadays people do just throw money at startups. But do you think there have ever been in the history of mankind, for instance, let's talk about Apple. When Apple was first starting up, do you think people were just throwing money at the Steves? No. And so they had to be very choosy about how they spent the money. They had to prioritize projects. And so that's what we're going to do here with this PI thing. Another example would be, in fact, I had a young lady sitting on the front row, and she was from Vietnam. And when I said that usually with big companies you don't have capital rationing, and she said, yes, we do. And I said, what do you mean? And she said, in Vietnam, that the banks are owned by the government. It's kind of like China. Banks are owned by the government. Now, there are two kinds of companies in Vietnam. There are state-owned enterprises, and there are private companies. Put yourself in the seat of the loan officer at the state-owned bank. And two people come to you, each wanting to borrow $1 million. One of them is a state-owned enterprise, and one of them is a private company. You only have $1 million to loan out. Who are you going to loan it to? The state-owned company. Number one, we're fairly sure that the government would step in and bail out the company if something went horribly wrong. Number two, my boss and their boss work for the same boss, right? Does that make sense? And so it turns out, in Vietnam, for private companies, and the same is true in China, you do experience capital rationing even when you've got a big company with mature, it's been around a while. And so our assumption of all the money that you need will always be there that we use with NPV may not necessarily be true outside of well-developed capital markets like the US or Europe. Does that make sense? Okay, so this actually, how we do it. So we start by ranking the projects by descending PI. What does descending mean? Ms. Ware?
Decreasing.
Yeah, decreasing. And so we're going to put our biggest at the top, and then we're going to start working our way down. And we're going to keep going down the list, accepting projects, until we run out of money. So let me say that we've got $1 million. We're going to talk about some different projects here. And we're going to have PIs for all of them. And then we're going to have cost for all of them, cost to get into them. So our first project is A. It has a PI of 3.2. Is that a good project? By the way, should we even put PIs less than 1 on this list? No, they're negative NPV. We would never invest in it anyway. So PI of 3.2, the cost is $500,000. Should I invest in that project? Absolutely. For two reasons. Number one, PI greater than 1. Number two, we have the money. How much money is left now? $500,000. Project B has a PI of 2.7 and costs us $250,000 to invest in. Should we accept Project B? Absolutely, because PI greater than 1 and we have the money. Project C, almost as good, PI of 2.6, costs us $300,000. What do you think, Mr. Fisher? He says we don't have the money, right? And that's what capital rationing is all about. We don't have the money. Now, at this point, do you think we should just throw up our hands and say, whoop, we're done? No, we've still got $250,000, right? And so Project D here has a PI of 2.1, and it just so happens is going to cost us $250,000 to invest in. I'm just doing that so we can bring this example to an end. Should we accept this project? Yeah, because it's great, PI greater than 1, and we have the money. Now, do we have another single penny? No. So by the way, this does point to the importance of putting in that 10% contingency, remember that I talked about with the upfront? Because otherwise, you've got all your money dedicated here, and then they're like, oh crap, we need to dig out the floor and put in a thicker slab. Then you're in a world of hurt, right? Because you've got no money. Okay, so that's how we would use PI. And so doing that gives you the biggest bang for the buck. It's an American expression, give you the biggest bang for the buck. Given the limited amount of money that we've got, this is the best we can do. Now let's talk about, I already talked about startup firms. Let's talk about another one, FEMA. And I actually had an engineer in this class, and he said, right there, and he says, oh yeah, we use this. And I said, what do you use it for? And he says, when you're making proposals to FEMA. Who is FEMA?
Federal Emergency Management Agency.
Yeah, people always have trouble with the last one. Is it administration? Is it agency? It's, yeah, whatever. It's not an association, but the A is really confusing. But FEMA, what do? Typically, they come in after, let's ask Mr. Taylor. Have you ever lived through a hurricane?
Yes, sir.
Who came to town after the hurricane blew through?
FEMA.
FEMA. And what kinds of things did FEMA do for you?
Like food and shelter and stuff like that.
Food, shelter, and they put those blue tarps on the roofs to keep the rain from getting, oh yeah, good stuff. Now, FEMA is in the business of cleaning up after problems. But you guys probably didn't know they were also in the business of trying to prevent problems. Can you prevent a hurricane? Let's ask Mr. Taylor. No, he says no. Okay, I was in Louisiana in 1996, and this is the thing that freaked me out the most. There's a hurricane warning, right? And my wife and I are like, ah, right? And because we're from this part of the country. And so we go to the grocery store, and we're like, water and canned goods and all this other kind of stuff. Mr. Taylor, what do people stock up on before hurricanes?
Water, alcohol.
Alcohol!
I was gonna say alcohol.
Oh my goodness, the
I'm from
Cajuns
Florida.
are loading
Hurricane
their carts
parties.
with all this. And I'm like, they're like, hurricane party! Yeah.
We don't worry until it's a Cat 4.
Yeah. Okay. Where were we? Oh, okay. So FEMA. So here's the trick. You can't prevent a hurricane. You can't prevent a tornado. Can you prevent flooding in the absence of putting in dams and things like that? You really can't prevent flooding, but we can prevent flood damage. And how do we prevent flood damage? Well, what we can do, oh, by the way, let me tell you where the money's going to come from for this. In the United States, we are so silly that we provide flood insurance as a government. So private insurers will not touch flood insurance, right? And so, in fact, when you get a mortgage on a house, one of the things they have to do is locate it on the flood map and make sure that you're not in the flood zone, or they're going to require you to get this flood insurance. And here's what the flood insurance does. Your house floods out, they come and they say, so let's assume Mr. Hawkes has a beautiful home, but it's down by the river. Now, why do people want to be by the river? They like to fish, they like to ride their jet skis, that sort of thing. So Mr. Hawkins has this beautiful home on the river. Now, here's the problem. He's only like 3 feet above the river. What do you think is going to happen if we get a big rain? It's going to flood. Mr. Hawkins says, oh, wait a minute. I've had some damage here. Flood insurance guy, come over here. And here's how silly our government is. They say, oh, Mr. Hawkins, we're so sorry. Here's some money. And now, do you think Mr. Hawkins says, whew, hold on not to do that again? Where does he rebuild? Same freaking place. 3 years from now, there's another flood. It's me again, right? And we're like, oh, here you go, right? Over and over and over again. It's so dumb. So, instead of just telling people, don't build by the river, what do? We set aside so much money every year, the Congress does. It sets aside every year, puts money aside and says, what we're going to do is we're going to put this money out there and people can then use that money to purchase these properties that are flooding out and then tear them down. Why do we have to tear them down? If we don't tear them down, what's going to happen?
People will vote back.
Yeah! And are they going to be savory people? Probably not. We call them squatters, right? So, what kinds of people? People who are looking to cook methamphetamine and not blow up their own house. That would be a good guess. How about lonely teenagers looking for love, right? That's another one. None of this is activity that we want going on federal property, which, by the way, this is not federal property because the government bought it. So what do? They go in and tear that stuff down, and then we declare that to be a recreational area, but not the kind that the teenagers had in mind, right? Okay, so back to the story. So, what happens? Every year, they put out the call for proposals, request for proposals. And all these engineering firms, they go out and they look at these nearby flood kind of stuff, and they put together a proposal for what they think it'll take to buy it and what they think it'll take to tear it down and put it into this new format that we're going, a recreational area or whatever. And then they calculate, for each one of those projects, they have to calculate the PI. Now here's the question. Where do you think the positive cash flows come from for this? You usually, remember, we've got investment up front and we get positive, positive, positive after that. Where do the positive cash flows come from?
Upfront on the list.
Say what?
What people using these after hours?
Yeah, so it's for the afterwards that we usually get positive cash flows. In this case, there are no positive cash flows. But what are we avoiding? The negative. Do you remember the whole patting him on the head, right? We are not going to be doing that anymore. And so what we do is we get a historical idea of how often these floods happen. We get an idea of how much it costs to fix when it does happen. And we make the assumption that we're going to avoid those going forward because after all, if we buy this place and tear it down, we're not going to have to fix it ever again. Does that make sense? Okay, so all these engineering firms all the way across the country put together their proposals. They have the PI and they write it, I think, probably in the upper right-hand corner. And then it goes off to Washington, D.C., where probably some unpaid intern at a desk puts them into descending order of PI. And they go through this project, and then for any projects that get accepted, they send a letter. Congratulations, your project's been accepted. If it's not accepted, they say, feel free to try again. Sorry, your project hasn't been accepted, but feel free to try again next year. Why? Because next year there may be more money available from Congress, or maybe there was just a bunch of really good projects this year, but next year they might not be around. Does that make sense? And so that's how you can use this even in a situation where you're not truly looking for profit. So, there's a problem though with PI, and the problem is one of the problems we see with IRR, and that is that it can lead to bad decisions for mutually exclusive projects. if you remember, the NPV for Project A was 24.34. Go ahead and write that one down. Project A, 24.34. And for Project B, does anyone remember what it was for Project B?
16.65.
No, your IR, that's the IRR.
Or 119.08.
Yeah, there you go, 119.08. It's 119.08 is the NPV for the second project. So now we're going to calculate PI for both of those. Remember, PI is just 1 plus the NPV divided by the initial investment. So initial investment for project A is 100. So we've got 24.34 divided by 100 is 0.2434. We're going to add 1. So write down PI of 1.2434. 1.2434 is the PI for that project. Now, on the other one, we have 119.08 divided by the initial cost of 1,000. And I believe that gives us something like 0.119. And we're going to add 1. And then the PI would be 1.119 and some other junk. Does that sound right? So, what sounds better? A PI of 1.2434 or a PI of 1.119? Yeah, so the snow cone sounds better. But this is because we have the same problem with this thing that we do with IRR. And that is that it fails to take into account the scale of the investment. And in fact, this one is so blatantly obvious because we take NPV and divide by that initial investment. And so if you have mutually exclusive projects, do not use PI. If you have mutually exclusive projects, do not use PI. Now the good news is that we don't have to worry about unconventional cash flows here. And the reason that we don't have to worry about it is because we're using NPV in our formula to find PI. And so it doesn't share that problem with IRR. It only shares this mutually exclusive projects problem. Questions? Okay. Now, so let's look at what goes on in the real world. It turns out that some finance professors got together and they sent out surveys to the top financial thinker at all sorts of different companies. And they busted these into large firms and small firms. Now, don't ask me to tell you what a large firm is and what a small firm is, but we're talking about difference in size. And then they said, how often on a scale of 0 to 4, where 0 is never and 4 is always, how often do you use these different measures? And they asked about IRR, NPV, payback, discounted payback, accounting, rate of return, and then the profitability index. And here is what they found. And that is that IRR and NPV are the top of the list, and they are used about as frequently as each other. Now, why would that be? It turns out you've got the same stuff to do IRR and NPV. If you're going to do one, you might as well do the other. And so when we do our NPV project here in class, I will show you how easy it is then to calculate the IRR. So that makes a lot of sense. Now, here's the question though. Why are these things more frequently used at large firms than at small firms? Any ideas? So let's assume that all firms start out small. In the beginning, it's just one person with an idea. And then things start to get crazy. They start to make money. They start to have to pay taxes. Who is the first financial professional they hire? An accountant, right? They hire an accountant. And so the top financial thinker at a small firm is more likely to be an accountant. The top financial thinker at a large firm is more likely, or at least they're likely to have finance people that would help guide them to the light here. Now, another thing, what do you think happens with the size of projects for large firms versus small firms? Does it sound reasonable that small firms might have smaller projects? Yeah. And so we said that with small projects, sometimes it doesn't make sense to do NPV or IRR. And so both of those things, that looks reasonable to me. And then we look at the payback method. And take a look at what happens here. We have a switch. Now we've got large firms doing this less frequently than small firms. And that comes back to two things we just mentioned. Number one, small firms are likely to lack sophisticated time value of money finance type thinkers. And the other thing is they're more likely to have small projects. So it makes sense that they're going to use payback more than large firms. And then we've got discounted payback, that dog with fleas. I don't even know why anyone would want to do that, but apparently some people do, so we'll scratch that one off. Accounting rate of return is more often used at small firms than at large firms. And who did we say the top financial thinker likely is at a small firm? Accountant, right? So it makes sense that that's more popular at small firms. And then finally, we have the profitability index. Now you say, wait a minute, this one isn't used very much at all. It must suck. And that's not the case. What I would tell you is the reason that it's not used more often is because in the United States, which is where all these firms are, we have very healthy capital markets. Typically, if you need money for a positive NPV project, you can get it. And so we don't have this kind of capital rationing. Now, of course, is that true across the board? Absolutely not. You can see that some firms still use that. So apparently we do still have some capital rationing, but not nearly as much as we would in a country like China or Vietnam, where they don't have really developed financial markets yet. Questions? Okay, that is the end of chapter 7. Now we are on to chapter 8. In the beginning, we said there are 3 questions we're trying to answer in corporate finance. What were they? Capital structure, which means how are we going to finance the assets of the firm? Very good. What's another one? Say again? What are we going to spend our money on? Well, it turns out there's 2 kinds of money. There's short term and there's long term. The first one is called a capital budgeting question. That's to deal with the long term capital budgeting question. And that is, what assets should we invest the firm's money in? And then we have finally the working capital question, which is the third one. And so the first one is, what assets are we going to invest in? And that's what this is all about. Chapter 8 is all about doing the analysis necessary to determine what you should invest in. And you're going to notice that we focus very highly in chapter 8 on net present value. And the reason we do that is because, after all, it is the gold standard. It is our only 3-star measure. So let's talk about some things we want to keep in mind as we do our capital budgeting. Number 1, we are only going to use real cash flows, not accounting numbers. What kinds of things cause accounting numbers not to be the same as real cash flows? Yeah, depreciation is a non-cash expense. Then we also have deferred taxes, which are a non-cash expense. A little shy today. There we go. Stop that. Okay, so deferred taxes. And then we also, if you think about it from the income statement perspective, we are treating sales on credit as if they are cash when we look at net income. We are treating purchases on credit as if we have cash outflows for those. And so there's all sorts of stuff that keeps our accounting numbers from representing real cash flows. So that's the first thing. Actually, that's everything that's on this, right? Okay. So now let's talk about incremental cash flows. incremental. A cash flow is incremental if and only if it will change as a result of making the decision. If and only if it will change as a result of making the decision. If we've got some sort of expense, and this used to drive me nuts when I was at one company. They were always, well, you know, every project has to bear its fair share of the burden. And so things like the corporate library would get a percentage of every project and all this other stuff that just got weighted down on it. And I would always respond, those cash flows are not incremental. Is the library going to cost any more to run as a result of taking on this project? No. Are we going to have to buy additional insurance if we take on this project? The answer is usually no, and so I don't need to pay for part of the insurance either. And so you've got to watch out for these things that people try to slip in there because they are not incremental. Cash flows that are going to occur regardless of our decision are not included. So things like the insurance, let's see, what was my other example there? Oh, the corporate library, and like the salary of the CEO. Is putting on this project going to increase the salary of a CEO? Probably not. So as a result, we should not be including a portion of the CEO's salary as a cash flow to the project. We do have cash flows that could happen if we didn't take on the project. And these are the trickiest ones to think about. And we do need to include those. So I'll give you some examples on that. But in the end, you got to ask yourself, will my decision on the project impact the cash flow? And if the answer is yes, the amount by which it gets impacted is the incremental cash flow. If the answer is no, forget about it and move on with your life. Questions? Now let's talk about sunk costs. What is a sunk cost? It's money that you've already spent that you can't get back regardless of the project decision. It's money you've already spent, you can't get back regardless of the project decision. So I'll give you an example from my own life. From 1989 to 1994, I went to engineering school. Do you think I invested a lot of time and money into that? Yeah. And so then I get out and I'm actually working as an engineer and it pays well, but not really what I wanted to do with my life, I figured out. And then I figured out, though, that if I come do this professor thing, that I can make good money. But should I think about all that time and effort I spent on that engineering degree? Should I let that affect my decision on whether or not to go to doctoral school? No. Can I get that 5 years of my life back? No. Could I get the tuition money back? Thankfully, the state of Arkansas gave me a full ride, which is cool. Thanks, Arkansas. But I couldn't get back the personal investment that I had in that. There was no way. So I don't need to consider that going forward. This is a common mistake that people make. I know a young lady, and she has been dating the same guy for 3 years. She recently got engaged to him, and she found out some things that let her know he will not be good husband material. Do you know what my advice to her was? Break up with him, right? In this life, you either, well, I guess there are 3 options now. One, you could just stay with someone indefinitely, but the old answers are get married or break up, right? And so I said, you know, you sound like he's a loser. You need to dump him. She's like, yeah, but I've got 3 years invested in this relationship. Is that good thinking? No, that's a sunk cost. Walk away, right? And then her mom says, yeah, sounds like you're going to save your 3 years so you can have 72 more miserable ones before you finally die, old and miserable and wretched? No, right? So it's a bad idea. But people think this way. Should we be including these sunk costs in our analysis? Are they incremental? No, they're not going to change regardless of the decision that we make. So when we're looking at projects, what kinds of things do we see that are examples of sunk costs? Well, the first one that we talk about is the marketing survey, the marketing survey. So let's say I am a goat farmer, and I've got a bunch of goats because I just love goats, and I have a goat dairy where we milk the goats. Now, how many of you actually like goat milk? Nobody. Okay. Goat cheese is okay. That's yeah, absolutely. And we'll talk about goat cheese in chapter 21. But back to the story. What I want to do is I want to find out if I put chocolate into this goat milk, will kids drink it? And if the answer comes back yes, then I may put in a chocolate goat milk line at my goat milk dairy. Okay, so what do I do? I'm going to pick on a marketing person other than Mr. Fisher. He's already given his all today. Do we have any other marketing people? We have a public relations person. She's as close as economics and what are you, Mr. McCann?
Marketing.
Oh! He was holding out on me. Okay, Mr. Huckes. I'm the goat farmer. How are you going to find out for me whether or not this works, this chocolate?
With a survey.
You can do a survey. So, can you just send out a survey in mail to people and say, hey, what do you think about chocolate goat milk? No, Ms. Perry, what do you need to do?
You have to do like an actual study, like goodness gracious, and give them a sample.
Exactly. We got to do the taste test, right? The goat milk
I hate when you
challenge.
get those surveys in the mail because the only people that are going to answer it is people that either really like goat milk or really don't like goat milk.
Yeah. So she's absolutely right.
Biases.
So here's what we have to do. We have to set up in a place that has a lot of people and usually a lot of kids. I used to would have said the shopping mall, but that's just not true anymore. So where would you go? Maybe Costco, and set up your booth. Now, Mr. Hawkes, I'm going to ask you this question. How much are you going to charge me to run this study?
$10,000.
Oh my, you're thinking so small. Every marketing study that I ever was involved with, and keep in mind this is 20 years, was $250,000. That was like the freaking magical number for marketing studies, was $250,000. So you're going to get paid $250,000. But I have to pay him regardless of the outcome. Remember, I have to pay him regardless of the outcome. Now, what if I thought, I'm going to be clever. Mr. Hawkes, I will only pay you if it turns out the kids like chocolate milk. What's Mr. Hawkes always going to tell me?
They like
Kids
chocolate
Kids
milk.
love chocolate milk. Because keep in mind that we're dealing with the kind of people who have the moral flexibility to tell 15-year-old boys that Axe body spray can get them lucky with the ladies, right? It's marketing people are a little flaky to begin with, but when there's $250,000 in the line, Mr. Hawkes is going to lie through his teeth, right? And so in order for this thing to be realistic, I have to pay him either way. Now, let's assume then that the market study comes back, oh yeah, kids love this stuff. In fact, it's the only way they'll drink goat milk. Now, I'm going to start doing my NPV project, my capital budgeting analysis of the chocolate goat milk dairy. Should I include that $250,000 as a cost? Absolutely not. That's money I can't get back regardless, right? It's money I can't get back regardless. And the same is true of environmental impact studies. Let's take California, for example. In the great state of California, if you want to build a gas station, you have to have several studies done. And one of them, they come through, you get archaeologists or anthropologists to look for proof of native habitation or whatever. And so basically they're going to look and see, did Native Americans live there? And if so, then there's going to have to be some preservation work that goes on. Number two, we have to have an endangered wildlife expert come out and make sure that we're not going to be killing off the last remaining 3 one-eyed newts or whatever, right? And so they got to come out and check that out. And then finally, we have to have the stormwater runoff people, the hydrologists, come out and tell us whether or not our project is going to hit any endangered waterways with runoff from gas station. You know, gas stations, there's always runoff, right? And so we have to hire those 3 people. Now, let's assume each of these people is going to charge me $100,000. each one of them comes back and says, yeah, you're good to go. So I pay them all their 100,000. Now I start to do my NPV. Should I include the cost of those studies in my NPV analysis? Ms. Avila says, no, why not?
Because regardless of if you can do it or not, you gotta pay.
Yeah, we got to pay these people regardless, right? And in fact, here's what I would advise you to do. Take the most likely to fail. Let's say that we knew there might be Native American settlement there. Get that person in first. Pay them their $100,000. Get your answer. If they give you the thumbs up, think about the second most dangerous thing that might happen, and that's the endangered species. There might be like one-winged bats or whatever hanging around there that you don't know about, but you've heard rumors. And so you get that person in there. And then if that works out, pay them their $100,000. And then finally you get the hydrologist in there. Does that make sense? And so, but those decisions are all prior to the capital budgeting analysis.